Good morning. What do you think of my pretty flower? Thank you. All right, so this flower, we've got yellow hexagons, red trapezoids, and green triangles. How can we describe the ratio of all the shapes that make up this pattern? Okay, so there's lots of ways. Here's the way I would do it. My yellow hexagons to my red trapezoids, to my green triangles, right? And so remember, way back from lesson 1A, the word two means these, and that order matters, right? So how many yellow hexagons do we have? 1, 2, 3, 4, 5, 6. How many red triangles? I mean trapezoids. 1, 2. And how many green triangles? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So sometimes your ratio can be more than more than two things you're going to compare. In this case, we were comparing three things. And in these three things, order mattered, right? We needed the yellow, the red, and the green in that order. Order matters. Question: how many total shapes would I need to make two of these awesome flowers? How many total shapes would I need? Well, there's a couple ways to go about it, right? So one is I could add a section, which I often like to do just for funsies, is the total. How many total? 6, 7, 8 plus 9 is 17. Okay, so then if I needed to double it, I would times everything by 2. 17 times 2 is 34, and I'd be done. Or if you're not comfortable with that way, don't do that way. Times these other numbers by 2 and then add them up. What's 6 times 2? Yeah, it's 12. 2 times 2, 4. 9 times 2, 18. Ooh, gosh. 18 plus 12 is 30, plus 4 is 34. Boom. Right? So again, a lot of different ways in order to do your math to get to the right answer, but you have to know how to correctly do those different ways. So a lot of times we'll just teach you one way to do it so that you have one good way you're for sure to know, and then sometimes we'll teach you a couple ways. Okay, and then you can pick which way you like best. All right. Next question. Let's talk about, just get rid of our flower here, and we will cordon this off so we can still use this paper. How about we do a recipe, and for one batch of cookies, we're going to need 5 cups of flour. Notice a different flour than we were just using, right? The other stuff was flour with a W and an E. 5 cups of flour and 2 teaspoons of vanilla. Obviously, there'd be more things in your cookies. At least I hope you know, obviously, if you just had 2 teaspoons of vanilla and combined it with 5 cups of flour, you will not get a cookie. Let me just break that to you. But also I wanted to talk to you totally off topic. See how I put this giant C here? That's kind of the universal symbol for cup. And a little t, I know we use it for time, but in recipe land, teaspoon. A lot of time for teaspoon, they'll put TSP. Just so you know, if you're ever reading a recipe and you're wondering, what are they talking about? That will help you. All right, let me see. If I were going to draw a diagram for that, it's this, right? I could put a line between them and basically I have a diagram. But what if I wanted 2 batches of cookies, right? This is one batch. What if I wanted 2 batches? We're going to have flour and vanilla, right? That part didn't change. But over here, how many cups of flour and how many teaspoons of vanilla will I need? Oh man. Here you go. If you already passed me and you're tired of listening, I apologize. But if you're not past me and you're glad I'm explaining, you're welcome. How do you get from 1 to 2 using multiplication or division? That's right. Times by 2. 1 times 2 equals 2. So to find out how many cups of flour you need, you'd take 5, bloop, go through the times 2. What's 5 times 2? Yeah, 10. And then 2 times 2 is 4. So to make 2 batches, you'd need 10 cups of flour for every 4 teaspoons of vanilla. Now, here's another question. What if, remember this is, I got to circle this so I know this is our original information, right? That's our original information because we're going to be talking about that a little bit. All right, question. What if I had 15 cups of flour? 1, how many batches could I make? And once I know how many batches, how much vanilla would I need? 15 cups of flour. Boy, that sure seems like a lot of flour. Well, okay, here's 5 cups of flour. How do I get from 5 to 15 using multiplication or division? 5 times 3 is 15 times 3. Okay, so what's 1 times 3? 1 times 3 is 3. I'd be making 3 batches. Okay, then 2 times 3, 6. I need 6 teaspoons of vanilla. Whew, that was a lot easier than I thought. How could I make a diagram that would be better than writing all of this all over the place? Let me show you. Let's change it up. Batches, flour, vanilla in teaspoons, in cups. One, two, three. That's the information we've done so far. One batch of cookies was 5 cups of flour, 2 teaspoons. 2 batches was 10 cups and 4 teaspoons. And then 3 batches was 15 cups and 6. Okay? Question. What if I wanted 5 batches of cookies? I guess we're having a real party if we need 5 batches of cookies. How much flour am I going to need? Am I going to need 20 cups of flour? Because all these just went up by 5. They do go up by 5, and so you'd think this was 20, but these were going up by 1 when these went up by 5. There's a ratio there. There's a relationship you're looking for. But then this did not go up by 1. And when this doesn't go up by 1, these can't go up by 5. Okay? Trick. So how do you get around the trick? Find the relationship. Are any of these numbers factors of 5? 3 times something equal 5? No. 2 times something equal 5? Well, nothing easy. No. How about 1? 1 times 5, right? So if 1 times 5 gets me to 5, what's 5 times 5? We'll use a pencil here. 1 times 5. So then here I got to go times 5. Because all of these have to be by the same or proportionate. Man, I'm throwing all these words at you today. 5 times 5 is 25, okay? Oh, so here I just have to times by 5 also. Proportionate relationships. 2 times 5, 10. Let me just tell you, that's a lot of cookies. I'm not sure we need all those cookies, right? Okay, so a lot of stuff thrown at you on this one, right? So here, remember we doubled our flour size. If we just wanted to know how many total pieces we needed, we could take the total times 2. But if you need to know the individual, right? And remember that ratios can be more than 2 things compared, and order matters, right? And then here we did a diagram. So we took our original information and we put it in a diagram to help organize our information. Organize it so you can use it later. So it's easier later, right? It's easier to see relationships when it's compiled in one spot. Okay? Good luck.